Hello everyone, and welcome to section 2.1 functions part 2, where we're going to kind of continue where we left off. Even though this is kind of disjointed, this section, this part 2 video isn't really closely related to the previous one, but there's a little overlap. But the first thing we're going to talk about is what we call the difference quotient. Now, honestly, this one is not super useful in terms of Math 126's material, but it is very, very useful later on in your mathematical career, specifically when you get to calculus. So we want you to get some practice now so that you'll be ready for it later on. And like when you take calculus, you'll be like, oh yeah, I remember this. So definition is that the difference quotient of a function f of x, or a function f, rather, is given by f of x plus h minus f of x over h. That is the difference quotient. That right there, that formula is the difference quotient. And as an important note about this formula, we have to simplify. We must simplify until the h in the denominator cancels. We are not done simplifying these problems until the h has canceled. If you try and put your answer unsimplified into MyLab, it will not count it. It'll mark it as incorrect. So we'll talk about how to deal with that in just a second. But if you're wondering what this is useful for, this has very, very big applications. I mean, like, this is legitimately the definition of the derivative, like minus the limit symbol, which you'll see in calculus. But this is what you need to compute the derivative and all its subsequent properties and everything like that. So this is very, very important, just not super useful in a practical context until we get to calculus. So let's go ahead and look at some examples. So for our example here, we're going to say find the difference quotient. Part A will be f of x equals 3x plus 5. Part B will be g of x equals 2x squared minus 4x plus 1. Part C, sorry, I didn't mean for it to zoom in there, will be y equals 1 over x plus 2. And part D will be capital P of x is equal to the square root of 4x minus 9. We'll go ahead and get into it. So for part A, we got 3x plus 5. Now, based on the way, don't worry, I'm coming right back to that for a second, but based on the way the formula works, it's nice to compute f of x plus h and simplify it first so that you don't have to do that all while you're computing this complex fraction at the same time. So I like to compute that on the side. So f of x plus h is going to be 3 times the quantity x plus h plus 5. By the way, before I even get started computing this, I'm going to tell you one of the biggest mistakes that students make here is algebra mistakes. I always recommend just putting things in parentheses right from the start, if you can. So we'll simplify this. That'll be 3x plus 3h plus 5. So with that in mind, the difference quotient, which is f of x plus h minus f of x over h, becomes, in parentheses, 3x plus 3h plus 5 minus, in parentheses. The parentheses are the most important on this second piece. Otherwise, you'll forget to distribute. I guarantee it. Maybe not this time, maybe not next time, but it'll happen eventually if you don't put the parentheses around it. All divided by h. And remember, we're not done simplifying until that h in the denominator has been canceled. So this becomes 3x plus 3h plus 5 minus 3x minus 5 all over h. Because that minus sign needs to get distributed. And then, luckily enough, the 3x's cancel and the 5's cancel. And so we just have 3h over h, and the h's cancel, and we just get 3. And for the record, by the way, it is always guaranteed that there is some algebraic way to cancel the h. There will be some way to be able to cancel it. So don't worry about, like, well, what if it doesn't cancel? It will definitely cancel. It just takes a second. Moving on to part B. We have g of x is equal to 2x squared minus 4x plus 1. So I'm just going to compute g of x plus h off on the side here. That's 2 times in parentheses x plus h quantity squared minus 4 times x plus h quantity plus 1, which becomes 2 times in parentheses x squared plus 2xh plus h squared minus 4x minus 4h plus 1, which will simplify to 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 1. And none of these things are like terms, so we can't combine anything here. And if you feel comfortable skipping algebra, you're more than welcome to. Just as a reminder, this negative 4 has to be distributed to both things. That's why it's a minus 4h. So, the difference quotient is g of x plus h minus g of x all over h, which in this case would be 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 1 minus, in parentheses, 2x squared minus 4x plus 1, all divided by h. Whew, that is a mouthful. But what you'll notice, when you distribute the minus sign in, and you can do this like if you want to do all the nitty-gritty details, you can, but when you distribute in that minus sign into everything, you'll see that the 2x squareds cancel, the 4x's cancel, and the 1's cancel. So what are we left with? We got that 4xh plus 2h squared minus 4h all over h. And just as a note, so don't write this down, but a lot of students will think that they can go like this and then be done with it, but that's not the case. You can, like, when it comes to a rational expression, you can cancel factors, but you cannot cancel terms. So the reason why this does not work is because this is a term in the numerator. We can't cancel terms vertically. We can only cancel factors vertically. But what we can do is we notice that everything here has a common factor of h. So we can factor that out front, and then we get h times 4x plus 2h minus 4 all over h. And now the h's cancel, and we have 4x plus 2h minus 4 as our answer. And since the h has been canceled, we know that we have simplified it enough. Moving on to part C, which was y equals 1 over x plus 2. We're just going to really replace this with f of x. We can do that. We can just write it in function notation. Well, that would mean that f of x plus h is 1 over x plus h plus 2. So the difference quotient, I'm not going to rewrite the formula just to save on time. This is going to be f of x plus h, so 1 over x plus h plus 2, minus f of x, so 1 over x plus 2, all over h. And remember, we're not done until we cancel that h. So there must be some type of algebraic manipulation that we can do. Looking at this thing, the only thing I can really see is to simplify the numerator by finding a common denominator. That's very simplify the big numerator by finding a common denominator within this little thing. So what I mean there is we're going to multiply this by x plus 2 over x plus 2, and we're going to multiply this by x plus h plus 2 over x plus h plus 2. So that'll be x plus 2 minus, in parentheses, x plus h plus 2 all over x plus 2 times x plus h plus 2 all over, this is where the big bar is, all over h. So the reason why I did that, by the way, like, feel free to look at my video, the videos on our Canvas page regarding Math 96, specifically rational expressions, talking about how to combine, like add and subtract rational expressions and or deal with complex fractions in order to figure out, like if you need a little bit of a refresher on this. But because they now have the same common denominator, I can just take the numerator here and the numerator here, and then have that common denominator. Distributing in this minus sign, we see that the x's will cancel and the 2's will cancel, and so what we end up with is negative h over x plus 2 rather, times x plus h plus 2 all over h. But dividing by h is the same thing as multiplying by 1 over h, right? So these end up canceling. And let's make that more definitive, though. That's going to be negative h over x plus 2 times x plus h plus 2. And I'm not foiling this out because that's actually unnecessary. We're really only looking to just cancel the h. We don't need to do any further stuff besides that. But anyways, dividing by h here is the same thing as multiplying the numerator by 1 over h, and we see that the h's cancel, but we still have that negative sign. So this becomes negative 1 over x plus 2 times x plus h plus 2, and that is our answer because we canceled that h. Last but not least is part D, which was p of x equals the square root of 4x minus 9. So that would mean that p of x plus h is equal to the square root of 4 times x plus h minus 9, which would be the square root of 4x plus 4h minus 9. Okay, so the difference quotient would be p of x plus h, so the square root of 4x plus 4h minus 9, minus p of x, which would be 4x minus 9, all over h. And as I said, we're not done until we cancel out that h. And now, like, this is a very, very tricky situation, and we just need to have a little bit of faith here to figure out how to get rid of this. So the thing is, we've got this difference of two radicals. And one of the things we may remember from our dealing with radicals before this class would be talking about conjugates. So if you multiply by a conjugate, in this case 4x plus 4h minus 9 plus the square root of 4x minus 9, and remember you can't just multiply the numerator by something, you have to also multiply the denominator by the same thing. So I'm going to write 4x plus 4h minus 9 plus the square root 4x minus 9. If we do this, the numerator here will obey the rule of the difference of squares thing. So a plus b, you don't need to write this, but a plus b times a minus b. If you multiply conjugates together, so this is our a, this is our b, and we're multiplying the plus version and the minus version together, this always ends up being a squared minus b squared. You can FOIL it out by hand if you'd like, but the fact is, when you multiply conjugates together, it just becomes the first term squared minus the second term squared. So, in this context, that would be parentheses square root of 4x plus 4h minus 9 quantity squared minus the square root of 4x minus 9 quantity squared all over h times the square root of 4x plus 4h minus 9 plus the square root of 4x minus 9. And this right here is going to be 4x plus 4h minus 9, and this is going to just be 4x minus 9 in parentheses because that minus sign needs to get distributed. Because when you square the square root, they cancel, and you'll see that the 4x's cancel and the 9's cancel, quite magically, honestly. And so we end up with is just 4h over h times the square root of 4x plus 4h minus 9 plus the square root of 4x minus 9. And the h's cancel, and we know we're done. This is a very, very tricky situation, and one that I would really only ask of my calculus students. There probably is one in your homework, but not much more after that in this context. So 4x plus 4h minus 9 plus the square root of 4x minus 9. And since we've canceled the h, we know we've got the right answer. And that's all we'll talk about for the difference quotient, and we'll move on to the next thing, which is what I like to call the algebra of functions. Sometimes it's called the combinations of functions, but algebra of functions will do just fine. So we need 4 definitions that are closely related to each other. So let f and g be functions. Then we have 4 sub-definitions here. The sum function is defined as wrong color. The sum function is defined as, in parentheses, f plus g of x, and it's exactly what we think it would be. This is f of x plus g of x. The difference function I wonder what this is going to be. Well, it's going to be f minus g of x is f of x minus g of x. That's just how it's defined. So basically the definition is that this is the name, like this is the sum function spoken f plus g of x, and how it's defined is just you take f of x and g of x and you add them together. Similarly for the difference function, f minus g of x is just defined as f of x minus g of x. Part 3. The product function is defined as f and a small dot g of x. Make sure that's a small dot. Later on, we're going to use an open circle. We're going to write this. It looks like fog, but it's like this is supposed to be kind of like a small circle. That's going to represent something completely different than this. So you can, like, some people, instead of just writing instead of writing a dot in between, they just write this, which is totally fine. And this is defined as f of x times g of x. And last but not least, the difference function, or sorry, the quotient function is defined as f over g of x, and it's just f of x divided by g of x. And you may be asking yourself, why? Why is this necessary? And that's a very, very good question. Part of it is to just get you to be used to using definitions and experimenting with them and finding fun things to do with them. But later on in mathematics, what this right here will do is this will define the set of functions as an algebraic structure, which can be useful in certain contexts. But the main thing for us right now is to just be able to like take a definition and work with it and see how we can deal with it. But before we move on to actually doing some problems with this stuff, I want to a lot of the questions that you'll see with these are going to ask for the domains of these algebra functions, the sum function, difference function, and so on and so forth. So the thing is, the domains of these functions are found by looking holistically. I don't know why I even put quotation marks, that's not necessary. Looking holistically at the function before simplifying. So typically speaking, when you see problems on this stuff, it'll ask you to find the function and then find the domain. When, in fact, sadly, that's going to be backwards of what you need to do with these problems. Because when you simplify the function, sometimes it removes information that you need to see. So when you're doing these types of problems, when you're asked to find the domain of these functions, these sum, difference, product, and quotient functions, first look at it holistically, then simplify afterwards. So find the domain first, then simplify, okay? So let's look at some examples. So, if f of x is equal to 2x minus 6. G of x is equal to x over x plus 2. And h of x is equal to the square root of x minus 11. Excuse me, just x minus 1. I messed up. X minus 1. Find the following functions. And their domains. All right. So part A will be f plus g of x. Part B will be f minus h of x. Part C will be f over g of x. And part D will be gh of x. So g times h of x. All right, so solution. Part A. F plus g of x is just defined to be f of x plus g of x. So we're just going to add those two functions together. So that'll be 2x minus 6 plus x over x plus 2. Now, before I go ahead and try and simplify it and combine it together, what I want to do is just look at this holistically to find the domain. This is good everywhere. Right? No matter what I plug in for x, this will always be fine. This is just going to give me a number. The second piece, however, is only defined as long as x plus 2 doesn't equal 0. So here, we need x plus 2 to not equal 0, meaning that x can't equal negative 2. So our domain, which we're going to find first, is just going to be negative infinity to negative 2 with parentheses on both sides, and then parenthesis, or union, parenthesis, negative 2 to positive infinity. That's going to be our domain. And once again, that's by using a number line and just plucking out this x value at negative 2. Now, to find to simplify it, what we need to do is we need to find a common denominator, meaning we need to multiply the first piece by x plus 2 over x plus 2. That becomes, so we get 2x minus 6 times x plus 2 over x plus 2 plus x over x plus 2. This is 2x squared plus 4x minus 2x minus 12. And if we add those two together, then f plus g of x will be 2x squared minus x minus 12 over x plus 2. And that's our answer. So the reason why it's minus x is because when we add the x, this negative 2x plus x becomes a negative 1x, and then we stick out that minus 12 and that 2x squared. And so that's the simplified version, and that's our domain. So you first find the domain, then simplify. Okay? Next, we'll move on to part B, which is f minus h of x, which is just defined to be f of x minus h of x. So f of x was 2x minus 6, and h of x was the square root of x minus 1. So just rewriting that, that's 2x minus 6 minus the square root of x minus 1. Now, luckily for us, this is already as simplified as we can get it. We can't combine in like terms. There's no like denominators to figure out. So we're just done at this stage. So we actually found f minus h of x without having to simplify. But then for the domain, once again, this is good. All good for the domain. Because no matter what you plug in here, you're always going to get a number. Whereas for this piece, we need to make sure that x minus 1 is greater than or equal to 0, meaning that x needs to be greater than or equal to 1. So that means that our function, f minus h of x, is defined to just be 2x minus 6 minus the square root of x minus 1. And our domain is bracket 1 to positive infinity. Because the first piece, no problems. The only thing that's an issue is we need to make sure that x is greater than or equal to negative, or greater than or equal to 1. So that on a number line, that would be from 1 to positive infinity. And that will be part B. Part C is very, very tricky. Part C was f over g of x, which is defined to be f of x over g of x, which would be, so f of x is 2x minus 6, g of x is x over x plus 2. Now, I don't want you to simplify because we're gonna talk about it in a second, but first things first is that here, if the denominator of this if the denominator of the big denominator, so this part right here, if this was equal to 0, we'd be dividing by 0, and that would cause problems. So we need x plus 2 to not equal 0. So we need x to not equal negative 2. However, since this is the denominator, it can't equal 0. Right? Since this is the denominator, like this is our main dividing line, so this is our denominator here, we can't have this equaling 0, meaning we can't have x over x plus 2 equal to 0, and that's a rational equation that we can solve by multiplying both sides. Let me use a different color. We multiply both sides of this equation by the LCD, which in this case would be x plus 2, and then we just get that x, we're going to make it not equal to, x can't equal 0. So we have x can't equal negative 2 and x can't equal 0. So on a number line, if you need help, that's going to be negative 2 here and 0 here. We're just going to pluck this point out, and we're going to pluck this point out. Everything else is fair game. So everything from negative infinity up to negative 2 is fair game. After negative 2 until 0 is fair game. And then from 0 onward is also fair game. So our domain is going to be negative infinity to negative 2, union, negative 2 to 0, and these are all parentheses, union, 0 to positive infinity. That's going to be our domain, and now we're going to simplify it. So we're dividing by a fraction, and if you divide by a fraction, you flip and multiply. So f over g of x is just going to be defined as 2x minus 6 times x plus 2 all over x. Or that'll be 2x squared minus 2x minus 12 over x. Either way should be fine. And I want to talk about this for a second. So as a note, if we simplified first before finding domain, meaning if we had just simplified and gotten our answer like this, we would have assumed that the only issue was x equals 0. So meaning, what I mean here is if we had simplified it, we'd get this expression, and that would lead us to believe that the only issue would be when the denominator equals 0, namely that when x is equal to 0. So we wouldn't have found this extra value that doesn't make it defined. Because if you try and plug in, if you go back to the beginning, if you tried to plug in negative 2 right from the get-go, you get f of negative 2, which would exist, but g of negative 2 would be undefined. So you'd be taking a number and dividing it by something undefined, and that's a problem. So that's why we have to look at it holistically before simplifying. So as we saw, that's not the case. So we need to first figure out the domain, then simplify. Okay? So move on to the last one, part D, which was g times h of x, which is just defined to be g of x times h of x, which would be x over x plus 2 times the square root of x minus 1. Now before there's not much to do to quote-unquote simplify it, but let's look at it holistically. From the first piece, we know that x plus 2 can't equal 0, meaning that x can't equal negative 2. From the second piece, we know that in order for the square root to be defined to give us a real number, we need the inside to be greater than or equal to 0. So we need this greater than or equal to 0, which means we need x greater than or equal to 1. Now, with that in mind, I'm going to claim that the domain is bracket 1 to positive infinity. Now why? Reason. Let's look at a number line. Here's -2, here's 1. Now, the blue tells us that we have to remove this point, and the red tells us that we need to be greater than or equal to 1. So the thing is that x equals -2, this is already taken care of by requiring x to be greater than or equal to 1. Since we need, since from the second part in the red, we need x to be greater than or equal to 1, it will never equal -2. So we don't even need to really, we don't even need to include this. It's what we call, in mathematics, if you want to sound really, really pompous, you can say that it is vacuously satisfied. So this condition that x can't equal -2 is vacuously satisfied by the fact that x has to be greater than or equal to 1. So that's our domain, and then our function g h of x is just going to be x square root of x minus 1 all over x plus 2. And that will complete our exercises here. And we just have one more quick problem to do that talks about a minor nuanced situation that we can talk about. So if f of x is equal to 12 over x plus 5 and g of x is equal to 3 over x minus 2, find f plus g of 1. All right, so solution. Now we could go out and find f plus g of x and then plug in 1 into it, but we don't need to, because by definition, f plus g of 1 is just f of 1 plus g of 1. So we don't need to find the sum function, we just need to plug in the values, plug in the x value 1 into f of x into g of x. That is to say, this becomes 12 over 1 plus 5 plus 3 over 1 minus 2. Plugging those into your calculator, simplifying them in your head, however you want to do that, that will be 2 minus 3, which will just be -1. So we didn't need to go through all the motions of finding f plus g of x. We could just plug in the values. I bring this one up especially because there's going to be some abstract problems that we'll do a little bit later that require us to just go straight from the definition. We don't need to find the actual function. We just need to find the values. So that'll about do it for now. Of course, there's the extra practice problems at the end. So I will, if you want to finish, if you're done here, I'll see you in the next video. Otherwise, stick around and we'll do a couple extra practice. So here are the extra practice problems. Feel free to pause to write down the problems, or if you just want to do them one by one, feel free to just stick around. So the first one, find the difference quotient of f of x equals 5x over x minus 4. So, solution. We should just find f of x plus h right off the bat so that we can just plug it straight into the formula. So f of x plus h is 5 times x, the quantity x plus h, over x plus h minus 4, which simplifies to 5x plus 5h all over x plus h minus 4. Putting this into the formula would therefore give us f of x plus h, which is f5x plus 5h, all over x plus h minus 4. Leave a little bit of space here, because we're going to have to do something to it, minus 5x over x minus 4, all over h. That's our f of x plus h minus f of x all over h. Now, just like before, we need to find a common denominator. So we'll multiply the first fraction from the numerator by x minus 4 over x minus 4. And we'll multiply the second fraction of the numerator by x plus h minus 4 over x plus h minus 4. And that'll give us 5x plus 5h times x minus 4 minus 5x times x plus h minus 4 all over h times x plus h minus 4 times x minus 4. And let's talk about what I did here for just a second. So because we're dividing the whole thing by h, that's the same thing as multiplying by 1 over h, which would just put it in the denominator of our new denominator in the numerator. That's a lot of statements, but this right here, this, let me use, this right here ends up being this right here. And then what I just decided to do is then I just put this h in the denominator after we combined everything. So with that in mind, let's go ahead and do some simplification. This will be, let's see here, 5x squared minus 20x plus 5xh minus 20h, then minus 5x squared minus 5xh plus 20x, all over h times x plus h minus 4 times x minus 4. And we see the 5x squareds cancel, the 20x's cancel, and strangely enough, the 5xh's cancel as well. So we're just left with negative 20h over h times x plus h minus 4 times x minus 4. And lo and behold, the h's cancel, so our final answer is negative 20 over x plus h minus 4 times x minus 4. And that is our answer because we have canceled the h, which means that it is simplified enough. Next, we'll move on to this one, which gives you a function f of x and g of x, and we want to find the sum function and the quotient function along with their domains. So solution. For part A, we have f plus g of x, which is defined to be f of x plus g of x. So in this case, that would be the square root of x plus 1 over x. And we can't really simplify that too much. If we wanted to, we could probably find a common denominator, but that's not too necessary. But what we need to do is from here, we need x plus 1 greater than or equal to 0, meaning that x needs to be greater than or equal to negative 1. And then from the second piece, we need that we need x not to be equal to 0. So that's two requirements there. And if we look at a number line, here's negative 1, here's 0. From the purple, we have everything greater than or equal to negative 1, and then we need to pluck out 0. So we have to have two parentheses around it. So our domain is going to be negative 1 to 0 union 0 to positive infinity with a bracket on the negative 1 and parentheses on the 0. So that's our domain, and then honestly we can just leave our function as is. So we can leave it as f plus g of x equaling square root of x plus 1 over x. If they gave you any flack on our homework system, you just want to multiply this by x over x so that you can combine the two. But that should be suitable. Part B. Part B is f divided by g of x. So that's f of x over g of x, which would be the square root of x plus 1 all over 1 over x. Now, we're not going to simplify first. We're going to first find domain. So from the numerator, we know that x plus 1 has to be greater than or equal to 0, which we already solved to be x is greater than or equal to negative 1. And then from the denominator, it can't equal 0, right? Because, like, this thing will never equal 0. But we need to make sure that the denominator does not equal 0. So we need to make sure that x can't equal 0. Otherwise, we'd have some number up here, and then we'd also have we'd be dividing that by something that's undefined. So those are our two conditions, which end up being actually the same conditions as above. So our domain is the exact same, actually. It's going to be bracket negative 1 to 0, parenthesis, union, parenthesis 0 to positive infinity. And our function, when we simplify it, we're dividing by a fraction, so we just flip and multiply. So our function, f over g of x, is just going to be x square root of x plus 1. And that is our function, thus completing this question. And we'll move on to the last one. which is given that f of x is equal to x squared plus 3x and f plus g of x is equal to 2x squared minus 9x plus 7, find g of x. So this is a fun little exercise in understanding, in definition chasing, essentially. So, we know that f plus g of x from the problem is 2x squared minus 9x plus 7. But we also know that by definition, f plus g of x is f of x plus g of x. So, and then furthermore, we know that f of x is x squared plus 3x. So, because these two things are equal and these two things are equal, we have that these two things are equal. That is to say, we have x squared plus 3x plus g of x is equal to 2x squared minus 9x plus 7. So that's f of x. We don't know what g of x is, and we know that their sum is equal to this. So we can just solve for g of x. By subtracting x squared from both sides and subtracting 3x, we get that g of x is equal to x squared minus 12x plus 7. And that is our answer. So, and you can verify that if you add this function to this function, to like if you add g to f, you will end up getting 2x squared minus 9x plus 7. And that'll about do it for today. So I hope you guys have a great day.